Right, we've got a Murphy base station here. Chances are we're going to have to take the bottom off, but for now we won't. He says the meter's duff on it, and we've got a standard mic with quite a long lead. The fact that the only leads we can get is the longer leads. I'm not even sure we can get those now, but we certainly could. So I'll take it apart, but we won't touch it. Now these always hum on transmit, so we have to accept that these always hum on transmit. We'll be doing the power supply, so it might hum a little bit less, but you have to remember it's a Spirit CB40F in a big box. The Spirit CB40F is a transportable, and I'll show you it. I understood that the Spirit CB40Fs weren't selling very well, and so what they'd got left were turned into base stations. These were a cheap base station, and I bought one brand new from Comet for £69.99 in 1982. So you can't expect it to be like an expensive base station. Now he's got a problem with the meter, so I'll see if I can do something with that for him. So this is a Spirit CB40F, and you will see the same knobs. There's lots of sames about it. And certainly exactly the same innards. So, these don't have a 12 volt provision. I'm going to have to rebuild the power supply first, but before we do that, I'm going to just power it up and make sure, well, see what it's doing and note it down. So the plug is a UK OK one. It's got the shrouded pins. Needs to have a 3 amp fuse in it. Unfortunately, it's a 13 amp fuse, so I'll need to change that. It's from a lorry company. Plug in the aerial. Plug in the mic, which is a unique pinout on these. So we're going to have to use the mic it's come with. And we will switch on. And it's come on 19. And it's transmitting, so this mic's not wired for this radio. Bit of a noisy volume control there. So that holds us up. I'll tell you what, because I have very limited time, some of these parts of these jobs are passed across to Mr. Chippy, and like the mic would be. What I'm going to have to do is start off by making up a mic. I'll get some of these parameters written down, but we'll have to make up a standard replacement mic so we can compare his mic to know whether things are working right. There's a lot of mics on the market which don't have screen leads, and it would be a nightmare if one of those was on this set, but that luckily is quite an older mic and it should be okay. So we'll have to rewire it. I'm going to have to make one up, but in the meantime, because it was making the radio going to transmit, I'll put that in and we'll read the transmit parameters without having to touch anything. So there we are in transmit. Let's put picture in picture on, and it's doing 3.5 watts. We'll just switch it to low power. So 3.5 watts. On low power it's doing 250 milliwatts. And if we switch it off, change channel, how do we do that? Unplug the mic, switch it back on, change channel to 40, put the mic back in, which will make it go into transmit, and it's doing 3.45 on channel 40. And we'll do the same again, unplug the mic. Okay, the power supply grunting, 3.5 watts. We don't know what transmit current is because it's on the main supply. So let's unplug the mic. It will now go into receive. Now, you haven't got an extension speaker socket on these, so we'll have to get the crocodile clip on our lead here. Should just need to connect the positive up because it should be getting the earth through the area. Nice big speaker in these. Right. We'll put the SINAD meter on. We'll put I didn't see what the frequency was it was on. Let's just try that again. So plug the mic in, which will make it go into transmit, and he's absolutely spot on. Wow. Can't ask for more than that. It's not often I don't have to touch it. Right. So unplug the mic again so it goes back to receive. RF gain to full. 27.7. There we go. Sounds a bit funny, like the IF's out. Let's put the SINAD meter on. For 12 dB we've got 0.65. For 10 dB 0.52. For 20 dB, it's not going to do that. 20 dB, it is 130 microvolts. So we'll put 100 microvolts on the test set now and see what the meter says. Well, the meter doesn't work. So, okay. I don't think either of the meter elements work in this. So, just check when I plug the mic in. No. All I can do is take them apart and try. It goes without saying you can't buy replacements. Squelch tight. So take the squelch to full, and let's see on the attenuator. We're at 100. Never opens. I've already lost my pen. Getting this recently. They've also sent an Amstrad in. I've done this first because we did an Amstrad not long ago. The one which had the case chewed a bit. This is another made in Japan one, so that should turn out really good. So squelch minimum, set threshold on the radio, signal generator back on. Oh, that's not good. No, that's not good at all. 6.8 microvolts minimum squelch. That tells me the IF is out of alignment. So nothing, nothing, nothing. Vol control dirty. Turn the volume down. It doesn't have that, and it doesn't have any of those. Speaker works. Mic rewire. Right, we're going to have to start with the power supply, just for our own sanity. We will check what's coming out of the power supply. .2, so it's not far out, is it? So the thing to do here is to change the 4 capacitors in the power supply here, and also that one in the radio. So that's the best possible thing we can do to try and do everything possible without modifications for that hum to not be there. Right. Can't say I like audio ICs not on a heatsink, but it is made like that. So it must be pretty well underrun. Right, I'll switch it off. Take the screws out of the bottom. Tell you what though, it's in good condition. You wouldn't think it was 40 years old. Things like fixing meters is probably something more likely that a hobbyist would want to do, because, you know, if I spend an hour on that, even if I'm on minimum wage as a tenner, you know, it sounds too much for fixing a blooming meter. It's pretty pointless. You know it's transmitting because the thing hums. Not even dust in the bottom. So there you are, and it says on the bottom spirit, because that's what it is. Right, I'll get on with it and get these capacitors changed. Right, I've got all the capacitors out, so let's see what we've got. So 1000 microfarads, 25 volts. That's about where it should be. It's getting replaced though. We're putting Nikon ones in. Whoa, faulty. So the one in the radio was faulty, the one in the power supply wasn't. $100 microfarads, 114 back where it should be. Faulty. You see, they're 40 years old, these now. That one's a little bit high, which can be indicative of imminent failure. So if we just, as a reference, check two brand new ones before I put them in. Of course, all these parts are smaller as time's moved on. They'll weigh less when I post it back to them. There we go. Good. Right, I'll get those put in. Right, that's got the new capacitors in. So, we'll power it back up. Set the power supply for 13.8 volts. It's always nice when you found some faulty parts. 13.21. Didn't say I could hold the prods on and twiddle it at the same time. .71. We'll leave it at 13.71. Right, that's that done. I'm going to have to look at the notes because I'm not sure what all the presets are. I think we're going to be transmit. I think that's going to be transmit. We're not going to start there. So I'll plug the mic in so that it shorts out the thingy and it goes into transmit. I must say it does sound less hummy. Well, fractionally. That was correct at peak. Ooh, got a fraction out to that one. I like to unkey in between, but it's not going to be that easy on this one. And there we have 4 watts. That's going to be the we're done with the spectrum analyzer one. So there we go, 4 watts. Let's see what we've got on other channels. Oh, got about 4.05 on channel 1, and on channel 40, I'm not even showing you the right meter, we've got 3.99, so it's about how it is. Right, we'll pause this and I'll go and fix this mic. It's either that or make up another one. Alright, so I've done their mic. Let's got our walkie-talkie on. Testing 1 2, testing 1 2. And now I've done one of our standard replacement mics so that we can compare. I want to do the rest of this with our standard replacement mic rather than their mic, because you never know whether it's any good.
Testing 1 2. Oh, good grief, ours is louder.
Yeah, I think there's is knackered. Right. So I've made some notes. Looks like VR, well, we can't do the meter ones, can we, at the moment, because the meter's not working. So let's go through the receiver, and I seem to have got, yeah, you're just T14 for the frequency on these. It's not a variable capacitor, but it's going to be that one, T14, but of course it's already on frequency. Yep. I'll just trim it a tiny little bit. There we go. Right, let's look at the receiver. It does sound wrong. So we'll start with the oscilloscope. Make sure we're still on frequency. We are. It sounds awful, doesn't it? That's 100 microvolts. And looking at the circuit diagram, the detector appears to be T8. So it's going to be that one. That's going to be T8, whether it says so or not. Oh, of course, got to connect the test gear back up to the speaker. That helps, doesn't it? Put delta tune to center position. So it was slightly out. And like we've had recently, the IF seem a bit out. And that seems like it's had blooming great big screwdriver in it. Right, I'll go to the SINAD meter. Drop to about 12 dB. Like that. Come back to that one. Right, we'll drop the signal to about there. Do the front end. Make sure RF gain's up. It is. That was already spot on. I think that was as well. Definitely peak there. Bigger signal for that one. Now the question is, does the squelch work? Yeah, the squelch does work. It's 1 microvolt. Good. So I must have got all that right. Let's see what it reads, because it doesn't seem lovely to me. So for 12 dB, it's actually worse at 0.8. So something's needs looking at again. I'm just going to go through this off camera. Okay, so we've now got 0.59. It's gone backwards and forwards and backwards and forwards. I think it's supposed to be 0.7 according to the manufacturer. 0.52. And 20 is 1.7. Better than 130, isn't it? So let's see what we can do with squelch. So I'll put the attenuator up on the screen and want it 100 microvolts. So of course it isn't coming in. Is it ever coming in? You see, it is coming in now, so that's good. It's coming in at 300 microvolts. So we've got a fighting chance now. I mean, we've got to appreciate this is a walkie-talkie in a big box, so you can't expect audio line 345 or Harrier CBHQ kind of performance, because it isn't. It's a £69.99 base station. That's cheaper than the Fidelity 3000. So I'm looking for variable resistor 2. That's 1. Be nice if it's that one, wouldn't it? Let's go for it. So it isn't that one. That says 4. That's going to be the deviation, isn't it? That's VR1. It is VR2. It is VR2. So so we can't have squelch therefore where I want it. There we are. So full sensitivity is, sorry, maximum sensitivity is 120 microvolts. So it's not far out from where I'd like it to be. So let's look at the sensitivity now. So we'll drop it down to nothing. Signal generator to standby. Squelch set on the radio. Signal generator back on. 1.35. That is not a sensitive squelch. I like them to be 1 or less. Right, so that's that done. I don't think it's got high-low power. So, variable resistor 1, S meter, variable resistor 2, squelch, variable resistor 3 I don't know, I couldn't find it on the circuit, and variable resistor 4 is going to be transmit power. No, variable resistor 3 isn't fitted, is it? So chances are that's going to be the power one, but until the meter's working, who knows. So I'll tell you what we'll do the deviation, and then we've kind of done the set. Then I'll dismantle it and see what we can do with the meter. So we'll plug into the test set behind, and see what it's got to say. Now that's not on, so I'll just have to come back in 10 minutes when it's warmed up. Right, I'm back. Let's see what we can get out of it. Wow, oh, it's a bit high. It's 4. In fact, that's at full, which is ridiculous. Wallow, wallow. Out of interest, we'll see what deviation can be developed out of their microphone. I actually think the element's incompatible. Well, you can get 2 out of it. Anyway, we'll do a comparison at the end of the on the air test, but I don't hold much hope. Right, getting connected back up to the Marconi test set. So at this point, normally we'd have finished the set, but we've got problems with these meters. So let's see what the deviation meter on this test set says, whether it's lying today or not. Oh, wrong one. Wallow. Spot on today. So it's 4 kilohertz. It's now 2.2 to 2.5 kilohertz. Right. What to do with this mic? Meter. Right, well, I'll take it apart and see if there's anything I can do. Okay, sad conclusion with the meter. The left-hand one is burnt out. It is open circuit. I've had a meter across it. I disconnected it, and it is open circuit. So there's nothing anyone can do apart from replace it with that off a scrap set. But a word of warning here: quite a lot of these, because I see I've got a duff meter. The other one isn't open circuit. The SWR one isn't open circuit. The trouble with the SWR one is that the bearings have jammed. So I kind of moved it around a bit, and you can see when I key up that it actually tries to move, but it's a jammed mechanism. So again, there's nothing you can do about that either. Again, I've got to say, this is a cheap radio. These are the kind of meters that were, 85 pence or something like that at the time. So it's a shame because it would be nice if it did, but you can tell it's transmitting because the pitch of the hum changes, and at least now the STR meter does shift. Let's put it in low power. So what did we not so we can't set up the, that's going to be transmit meter. We know this one VR1 is receive, and that leaves us with, we've done squelch, we've done deviation, it leaves us with an unknown. Now I wonder if one of these is low power. I'm going to tread carefully. So we'll switch the radio to low power, and very gingerly I don't think it's adjustable. No. Good. Well, that's got to the end of that. So we've got the set working, and I'm just sad that we can't do anything with that meter, because sometimes we can. Right. So we're all done. I need to put some switch cleaner on that volume control. Put the lid on it. We'll do their Amstrad tomorrow, which I know the bar graph display drivers failed on it. That can often be because it's been reverse polarity. In fact, it's the only reason I would have thought it would cause that. So I just hope that that's all that is wrong with it. It's always possible that it has been reverse polarity. Someone else has changed the ICs that takes out, like the audio chip and the receiver chip, but perhaps they couldn't get the display driver, which is BA656. And it isn't that easy to get. They were obsolete pretty early on. Mind you, I remember when they were 85 pence from East Cornwall Components. But luckily, I do have some. I have cleaned the front panel to this. It has delaminated slightly round here. So although I thought, oh, it's got nicotine or something, but it hasn't, it's delaminated. Okay, so we'll swap the test gear for the aerial. So this isn't the most sensitive set in the world, but it does what it's supposed to do. One and a Roger. One and a Roger. In for high power. Right, we'll do an on-the-air test on that. So that's with our mic. I say when we do the on-air test, we'll go over to their mic, but I'm not holding much hope for it because I think the element's incompatible. So thanks for watching the Murphy CBH1500, which is the Spirit 40F in a big box.